Welcome, students. Today we're going to look at an introduction to polynomials. We're going to start with a lot of definitions so that we can make sure we understand what a polynomial is and so that we have the vocabulary to talk about polynomials. And then afterwards, we're going to spend a little bit of time adding and subtracting polynomials, which shouldn't be that bad. So first, we want to define what a polynomial is. A polynomial is an expression whose terms are in the form ax to the n power, where a is any real number and n is a whole number. We're going to start by looking at some examples of polynomials and some examples of expressions that are not polynomials. So first, let's look at some polynomials. We have 2x cubed plus 5x squared. That's one polynomial. X squared minus 3x plus 7 is another one. 9x to the fifth is a third example. And it doesn't have to be x, it can be y. Y cubed plus 8 is a fourth example. These are all polynomials. If you look at the terms, it's a number times x to a power, a number times x to a power, and these powers are all whole numbers. We're also allowed to have just a number times x, because technically that's the same thing as x to the first, and constant terms are allowed because technically 7 is the same as 7x to the 0. I don't want you to worry about that technicality too much. Just know that we're looking at a number times x to a power, where that power is a whole number, or a constant term. Now let's look at some examples of things that are not polynomials, just so that we can compare and contrast. Not polynomials. We have x squared plus x to the negative third. We have 3x minus x to the 1/2. We have 1 over x cubed minus 2x, and the square root of x plus 1. And I want to talk about why each of these is not a polynomial. Let's look at the first example. Both of these are powers of x. However, the second one has a power of x that's a negative number, and that's not allowed. We need the exponent to be a whole number. So 0, 1, 2, 3, 4, etc. Let's look at the next example. Again, we've got terms that are a number times x to a power. The problem here is that we've got a fractional exponent. That's not allowed. All right. In the third one, we only have positive exponents. However, here we have an x cubed in the denominator. That's not allowed because technically an x cubed in the denominator is really the same as x to the negative third if we bring it up to the numerator. So we can't have things like variables in denominators in general. And lastly, in this last example, the square root of x is not allowed. That's not x to a certain power. That's the square root. That's something completely different. So hopefully you can see the difference between what is a polynomial and what is not a polynomial. All right, I want to move on and look at some more vocabulary just so that we're all on the same page and we can talk about polynomials. In the term ax to the n power, a is called the coefficient of the term and n is the degree of the term. So the number out front that's being multiplied by some power of x, that number out front is called the coefficient, and then the exponent we call the degree of the term. So if we look at this first example, the first term has a coefficient of 2 and a degree of 3. The second term has a coefficient of 5 and a degree of 2. In the next example, the first term, if we look at the coefficient, there's not a number written in front of the x, but we know that we can always multiply something by 1 without changing its value. So the coefficient of that term is 1, and the degree is 2. For the next term, the coefficient is negative 3, because it's being subtracted, because it's a negative term. We know that the coefficient has to include that negative. So we've got a coefficient of -3 and an exponent. What exponent could we put here without changing the value? Well, the answer is 1. So the degree of that term is 1. When we have a constant term, the degree is 0 because there are no factors of x. All right, let's go through these last ones quickly. Here, the coefficient is 9. The degree is 5. In this polynomial, for the first term, the coefficient is the invisible 1. The degree is 3. Here, the coefficient is 8, and the degree is 0 because there's no powers of x. Okay, and then we have two more definitions here. The degree of the whole polynomial is the degree of the term with the highest power, and we call this the leading term. So here, in this first polynomial, the term with the highest power is 3, so we say the degree of this whole polynomial is 3. It's a third degree polynomial. This is the leading term. We also sometimes talk about the leading coefficient. That's the number, the coefficient, on the term that is the leading term. For this one, the highest degree is 2, so the degree of this polynomial is 2. The leading term is this x squared, or 1x squared. Here the degree is 5, and this is the leading term, it's the only term. And here the degree is 3, and the leading term is y cubed. Now, in all of these examples, the leading term was the one that came first. That's not always going to be true because we can rewrite these in different orders, right? I could decide to change the order here and write 5x squared plus 2x cubed. However, we usually write them with the highest degree first and then the smaller degrees coming after that, and that is called standard form. We usually write polynomials in standard form from the highest degree term downward. Let's look at two polynomials that aren't in standard form, and let's write them in standard form. So let's take a look at 3 minus 2x plus 8x squared. This is a polynomial. All the terms are a number times a variable to a power, or a constant term. And those powers are all whole numbers. Now, if we want to put this in standard form, we've got to start with the highest degree and then work our way downward. The term with the highest degree is this one, so we're going to start off with that 8x squared. Then the next one is going to be negative 2x. The degree of that is 1. And then we always have the constant term at the end, because constant terms have degree 0. That's always going to be the smallest degree. So we've just rewritten this in standard form. Let's do another one. Let's look at 3x cubed minus 1/2 x to the 5th plus 1 minus x. Now, some of you might be thinking that this isn't a polynomial because there's a fraction. However, that fraction is the coefficient of a term, not the exponent. We're allowed to have fractions as coefficients. We can also have decimals as coefficients. The coefficient can be any number. It's just the exponent that has to be a whole number. So let's write this in standard form. The term with the highest degree is going to be this one. So we're going to start off with negative 1/2 x to the 5th. Then we have positive 3x cubed. And then there's no x squared term, so we go into the x term. That's going to be minus x, and the constant term plus 1. Good. All right, I hope you're not sick of vocabulary. We have 3 more pieces of vocabulary, and then we're done with vocabulary for now. It's a very heavy vocab unit because we're looking at something new, and we need words to use to talk about what's going on. So 3 more terms. I'm going to write these out by hand just to switch things up a little bit. A monomial. And when I write a definition, I can't write something in bold, so I will underline it. In fact, in your notes, you probably want to be underlining the words that you're defining. It's a good habit to get into. A monomial is a polynomial with one term. And an example might be 3x to the fourth. Just one term. We call it a monomial. It's also still a polynomial, but we have a special word for the ones that only have one term. Next, a binomial is, what do you think it is? A polynomial with two terms. Good job. I'm going to guess that you guessed that correctly. Oftentimes students can tell. For example, 3x to the fourth minus 5x cubed. That's an example of a binomial. Now, what about a trinomial? Any guesses? Exactly, you're right. It's a polynomial with three terms. Like 3x to the fourth minus 5x cubed plus 12. And then one more, quadnomial is not a word. We stop labeling with trinomial. Because we deal with monomials, binomials, and trinomials so often, those three categories get special labels, but after that we stop labeling because we need to stop somewhere. If we came up with words for 4 terms, for 5 terms, for 6 terms, for 77 terms, it would go on forever and we'd have an infinite amount of vocabulary. And I think you'll agree, nobody wants an infinite amount of vocabulary involving math. The 8 or 9 definitions that we've gone through already is probably enough. All right. In the next video, we're going to actually do a little bit of arithmetic with polynomials so we can actually do something instead of just writing out definitions.